All right, in this video, we're going to start talking about alternating series. This is notes 8 of Calc C, and alternating series are kind of neat, and they're pretty easy to work with, and so that's good. All right, so a whole new type of series. You may have noticed, potentially, I definitely mentioned it in the last video, that most of the series that we work with have been exclusively positive termed, right? So the ratio test and the root test throw absolute values around things, so they could deal with series that were sometimes positive, sometimes negative. Geometric series, they don't seem to care about anything, positives, negatives, as long as r is less than 1, the absolute value of r is less than 1, they're good. Alternating series will give us a means of dealing with series that are strictly alternating. Now, strictly alternating means that no two consecutive terms have the same sign. So this needs to be true if a series is going to alternate. So you can go plus, minus, etc. You can go minus, plus, etc. You can't go minus, plus, minus, or anything like that. That's not going to do it. And it's interesting. You actually can make that happen. So let's see which of these alternate. So here, write out the first 6 terms. So I'm not going to expand them. I'm just going to write, you get 0 factorial minus 1 factorial plus 2 factorial, 3 factorial. Every time it's even, you get plus. Every time it's odd, you get minus. And that should be 6 terms because also, well, this should be approximately then. Approximately. This is alternating, right? We're going positive, negative, alternating for sure. That's good. How about this one? So, all right, we plug in 0, we get negative 1 over 1. Plug in 1, we get plus 1 over 2 minus 1 over 3 plus. It takes a little, once you get it going, you got it, but it can take a second to see the pattern. And then it's approximately, because we're only partial summing this, this is alternating. It starts negative, but then negative, positive, negative, positive. So it starts negative because the plus 1 and the 0, right, like forces it to be negative 1 to the first. And so that's negative, and then it's going to alternate from there. All right, this one, I don't know. So if n is 1, if n is 1, we get 1, 2 divided by 2. 2 divided by 2 is 1, so we get negative 1 to the first. And then if n is 2, we get 2. 2 over 2 is just 1, so we get negative 1 to the third, so that's minus. If n is, so what is this? This was n is 1, n is 2. If n is 3, we get 4. What are you? We get 4 divided by 2 is 2 times 3 is 6, so that's positive. So that was when n is 3. This is annoying. When n is 4, switching all these devices here. When n is 4, we get 4 divided by 2 is 2 times 5 is 10. That's even, so it's plus. When n is 5, we get 6 divided by 2 is 3 times 5 is 15 is odd, so it's minus. This is kind of interesting. Minus, minus, plus, plus, minus. So that's 4, 5. When n is 6, we get 6 over 2 is 3 times 7 is 21 is odd, minus. Oh, okay. So this goes minus, minus, plus, plus, minus, minus, and it'll keep doing that, I think. Not strictly alternating. It's like kind of alternating, but not strictly alternating. This is a very cool exponent that makes that happen. I really like that. So that's not strictly alternating. It's sort of semi-alternating. And then this, oh God, this gives us the sine of 3 over 2 plus the sine of, so 5 over 5. That's not always going to be the same. 3 gives sine of 7 over 9 minus 1 is 8. Okay. Then sine of 9 over 11. 1, 2, 3, 4. Sine of 11 over 14. Sine of 13. So it's all the odds, over, like I just keep adding 3 in the denominator. It's like a line, right? A linear function, 3n minus 1. So just keep adding 3 once you get the first one. So is this alternating? I don't know. 3 radians is in the second quadrant. 5 radians is like 3.14 plus 1.5. This got to be in the, this is in the fourth quadrant, so negative 7. That's first quadrant. 9. It's like 6 plus this. I think is second, so that's positive. This, I don't think this is strictly alternating, right? Like you're always adding 2 radians, and 2 radians is like 120 degrees, so you're bouncing like quadrants. This one's all over the place, like sometimes positive, sometimes negative, can't really be determined. Also a giant pain in the neck. So strictly alternating with this, with this. So -1 to the n plus 1, -1 to the n, strictly alternating. Some weird nonsense, and then just like too much thinking. So strictly alternating, you want to know there are ways to do it. -1 to the n, sure. -1 to the n plus 1, definitely. Cosine of pi times n is actually a really common thing for your calculator to spit out. When your calculator doesn't know what to do with a -1 to the n, it changes it into cosine of pi times n. I don't know why. But it does it, right? So like when n is 0, you get the cosine of 0. Cosine of 0 is 1. When n is 1, you get the cosine of pi. The cosine of pi is -1. Then you get cosine of 2 pi back to 1 rather, and then -1, 1, -1. So this actually alternates. I've never seen this one in practice, but it could happen because like you're just alternating the y-axis of the unit circle. So you're going from like a positive 1 y value to a -1, positive 1, -1. So like, you know, could happen. I've never seen it. We need to know when something is strictly alternating because we want to be able to use the alternating series test. So the alternating series test, it's a good one. It's a big one. It's really close to the last one that we're going to learn. So alternating series test says, now it's weird the way it's written. So a sub n is greater than 0, and then you just throw in your like -1 to the n or -1 to the n plus 1. So a sub n itself is positive, and then you make it alternate using -1 to the n or whatever, some alternator, right? So this series converges. I triggered Siri, the device thing. It converges if the terms alternate, which means it's an alternating series. It's the alternating series test. They better alternate. Then number 2 is the tricky one. If for all n, a sub n plus 1 is less than or equal to a sub n. So it just means that the terms decrease in magnitude. So the absolute values of the terms, if you like get confused, they decrease in magnitude. And then the third thing is that the limit has to be 0. So those 3 things need to be true. Alternates, decreases in magnitude, limit is 0. If those 3 things are true, series converges. So a little bit to keep in mind about this. If it's not alternating, like what are you even doing, right? Why are you using the alternating series test? So if number 1 isn't true, don't apply the test, whatever. If number 3 isn't true, if the limit as n approaches infinity of a sub n is not 0, then it diverges by the nth term test anyway. So really number 2 is the tricky one. In Calc BC, you just don't run into that scenario. So you don't really need to worry about it. So we're not going to talk about it very much, but 2 is it's like the linchpin. That's where it could go wrong or not go wrong, depending. So we're going to check alternating, decreases in magnitude, has a limit of 0. If those 3 things are true, convergent alternating series. So I'll be back in the next video to probably do some problems. So I will see you there.